lecture of game theory. So in the previous lecture, we covered the concept of Nash equilibrium and the concept of a pure strategy. And today we're going to make sure that you understand the concept of a pure strategy. And I'm going to do that by examples. So let me kind of remind you a little bit what was a pure strategy. So I'm going to bring back the definition of what we said was a pure strategy. So let's kind of copy that. So a pure strategy assigns one action at every decision-making point for all possible histories. Okay, and we know all this stuff, so we can delete this. And we'll, in the same time, we'll exercise with some of these ideas here. So let's first start with a following example. Let's say that we have two firms, and they can decide to have strong or weak competition. And let's say that both firms decide simultaneously, so at the same time. Well, this kind of game can be represented as firm 1. This is a normal form game. Firm 2, let's say strong versus weak, and I can make some payoffs. Let's say they're both strong, they kind of hurt each other. If one is strong, the other is weak, the other ends up gaining more than the other, and let's assume that the game is symmetric. So 0, 2, and let's say they're both weak. Let's say they both earn 1. Okay. So imagine that you're dealing with this game, and let's ask a few questions. What is the number of decision-making points for each player, right? Well, it's a symmetric game. So in this case, because they take this decision simultaneously, there's only one decision-making point. Okay. Let's just put out the number of actions. Well, in this case, there is only 2 actions, either S or W, so strong or weak. But here's another crucial question, because a strategy, right, needs to assign an action at every decision-making point, but for all possible histories. So at each decision-making point, we need to ask the question of how many possible histories. Well, a history is a collection of action for previous players. We do not have previous action, so the history is just 1, or the empty set, or the game has just started. So in that particular decision-making point, we only have 1 history. So what would be a pure strategy for a player? So let's say strategy for player 1. Well, it needs to assign an action at every decision-making point. Well, there's only 1 decision-making point, but for all possible histories, but there's only 1 history. So there's only 1 action to be assigned. So in this particular case, strategy could be S, for example. What's the number? So this is an example. So I can say an example of a pure strategy. An example of pure strategy. And I could ask the question, what's the number of pure strategies for each player in this case? Well, the answer to that is simple. The number of pure strategies is just 2, and it actually coincides with the number of actions. Now, to really understand the definition of a pure strategy, here's something that I know most people that are studying game theory for the first time will find it very hard to kind of follow this through. Imagine, and now I change this game a little bit. Now I say assume the first firm moves first, and firm 2 observes firm 1's action prior to taking its action. Well, in this particular case, perhaps a more suitable representation of the game is what's called an extensive form game. So we'll have firm 1 here. So the bubble indicates a player where a decision needs to be made. The lines indicates an action, so you can decide to be strong or weak. And player two, or firm two in this case, having observed whether the player one is played strong or weak, can also make a decision to be strong or weak. And we said if they're both strong, they kind of lose out, both -1. And you could say this is firm one's payoff, profit with a pi, firm two's payoff. Strong player here wins 2 versus 0. And if they're both weak, what did we say? If they're both weak, they get 1-1. And the weak one gets 0, the strong one gets 2. Okay, so this will be a better way to represent that game. Now, I'm not interested in solving this game in this video. I'm really just interested in you learning the mechanics of what is a pure strategy here. So I'm going to ask the question of, now the game is not symmetric anymore, so both players need to be done separately. So I'm going to do firm 1 here and firm 2 here. Okay, so I'm going to get a little tree here, firm 2. And I'm going to start kind of asking the similar question that I asked. What is the number of decision-making points for firm 1? Well, that's easy, it's just 1. What's the number of decision-making points for firm 2? Well, that's also just 1. They only have to make one decision, right, during the game. Now let's ask a different question. Remember what the pure strategy is. It needs to assign an action at every decision-making point, but for all possible histories. So we need to ask the question, in this particular decision-making point here, in this particular decision-making point, what's the number of histories? Well, in this case, the empty set is 1. Player 1 is just starting the game. There is no previous actions available. Now, this is a much more interesting question, so I encourage you to pause the video. What's the number of histories here? So if you look at the definition of a history, the number of histories here is going to be 2. Okay. So what is a strategy for firm 1? Well, there's only one decision-making point and only one history. So a strategy for firm 1 could well be, for example, S. But a well-defined strategy for firm 2 would need to assign an action at every decision-making point, but for all possible histories. So in the first decision-making point and the only decision-making point, there are 2 histories. One history could be that the strength was observed, in which case, for example, I could play strength. And if weakness was observed, I could also play weakness, for example. That could be one possible strategy. Now, if I were to ask you, what is the number of pure strategies here? Well, you would hopefully by now say confidently, this is 2. Okay. Now, what's a bit more tricky if I were to ask you what's the number of pure strategies here? And I invite you to pause the video for a second. You could, of course, list all the pure strategies here. The right answer is 4. You could list all of them. So SS is one, WW is one, SW is another, WS is the other. It's assigning a different action to different histories. So there's 4 pure strategies. So if I would want to represent this game in a normal form game, one of the properties of a normal form game is that you need to list all possible strategies, all possible pure strategies. So for firm 1, I could say there's only 2 pure strategies, S or W. But for firm 2, because an action needs to be assigned at every decision-making point for all possible histories, there's 4 such strategies. So it could be SW, WS, SS, WW. And from there, I can figure out the payoffs that would come up from those combination of strategies. But my goal was just so that you can learn how to count this profile of strategies. Now, here's a challenge for you, and I'm going to address this in the next video. Challenge. 2 players play 2 rounds of rock, paper, scissors game. How many pure strategies does each player have? Because the game is symmetric. Now, if you can solve that, and it's hard on a couple of levels. One is the concept of what is a pure strategy, and the second one is combinatorics, or learning how to count. You would be cleared for the concept of a pure strategy. I hope this helped. I'll see you on the other video.